Good morning, all. Welcome you all to the Class 11 Mathematics classroom. Before starting the class, I would like to congratulate all of you for achieving glorious victory in your 10th standard examination. Dear friends, we want to proceed that victory here also. For that, we want to learn, understand, moreover enjoy all the subjects that are here for your higher secondary course. As you know, mathematics is one of the very important subjects that you have to study. By learning mathematics, you may feel your other subjects like physics and chemistry are also more easy. Dear children, I have a simple request, each one of you. That is, you want to do 3 things while listening my class. First one is, write your notebook beautifully. Second point, study your portions regularly. And third one, attend whole classes from beginning to end sincerely. Now, let us familiarize the whole chapters that we have to learn in our class 11 mathematics. Our first chapter is sets, second chapter relations and functions, third chapter trigonometric functions, fourth one principle of mathematical induction, complex numbers and quadratic equation, linear inequalities, permutations and combinations, sequence binomial theorem, sequences and series, straight line, quantisections, introduction to three-dimensional geometry, limits and derivatives, mathematical reasoning, statistics and probability. Today, we are going to learn our first chapter, sets. Set is the basic chapter. That is, it is a fundamental chapter of all higher mathematics. So, give enough importance to this chapter. Try to learn it clearly without any doubts. Before starting the chapter, let us have a look at the history of set theory. George Cantor is considered as the father of set theory. He born in 1845 in Russia and died in 1918 in Germany. He spent his entire life to learn, teach and propagate mathematical ideas. He worked as a professor in Halle University, Germany. One of his famous theory was about infinity of infinities. Dear children, once George Cantor said that to ask the right question is harder than to answer it. So keep this in your mind and make to practice in your life. Dear, sometime some of you may weaker in mathematics, but don't afraid. Listen to the word of Abraham Lincoln. I walk slowly, but I never walk backward. So, even if you are walking slowly, don't afraid. You don't walk backward. That is the important thing. Now, it is the time to start our first chapter, set. Set, by the word set, we mean collection or group. In our daily life, we come across different collections. Just like us, collection of bangles, collection of pens, collection of human beings, etc. See some examples. First example, the collection of all even natural numbers. Which are the even natural numbers? What is the smallest even natural number? That is 2. Then 4, 6, 8, etc. That is the collection of even natural number. We mean 2, 4, 6, 8, etc. We can definitely say these are the numbers that belong to this collection. What about 1? Is this belong to the collection? No. 5 does not belong to the collection. These numbers 2, 4, 6, 8, etc. are the even natural numbers and hence they belong to the collection. See another example. The collection of all vowels in English alphabet. Which are the vowels in English alphabet? A, E, I, O, U. We can definitely say the letters which belong to the collection, and we can say the letters which are not in the collection also. For example, Q is not a vowel and hence Q does not belong to the collection. X is not a vowel and hence X is not belong to the collection. Okay, another example is the collection of all districts in Kerala. We know that there are 14 districts in Kerala: Trivandrum, Kollam, Pathanamthitta, Alappuzha, Kottayam, Idukki, etc. And we can definitely say which places, which districts are the districts in Kerala and which are not in Kerala. Okay, another example is the collection of all prime factors of 20. What are the factors of 20? 1, 2, 4, 5, 10 and 20. Among them, 2 and 5 are prime factors. By prime factor we mean the number which has only 2 factors, 1 and the same number. 2 has 2 factors, 1 and 2. 5 has only 2 factors, 1 and 5. These are the prime factors of 20. Hence we can definitely say the object or the numbers belong to the collection are 2 and 5. 10 does not belong to the collection, 100 does not belong to the collection, 20 does not belong to the collection, and so on. And the last example, the collection of a solution of s square minus 5s plus 6 equals 0. S square minus 5s plus 6 equals 0 is a second degree polynomial. It is a quadratic equation. By the solution we mean the value of x. How can we find the solution of this equation? For that we find two numbers such that their sum is negative 15 and product is 6. Negative 5, sum is negative 5 and product is 6, which are the numbers minus 2 and minus 3. We can write s square minus 5s plus 6 as the product of linear factors s minus 2 into x minus 3, and hence this equation become x minus 2 into x minus 3 equals 0, that is x minus 2 equals 0 or x minus 3 equals 0. Therefore the two distinct solution of this equation is x equal to 2 and x is equal to 3. That is the collection, the numbers that belong to the collection is 2 and 3. Clear? These are the 5 collection, and this 5 collection has a common property. That is, we can definitely say what are the objects, what are the elements that belong to this collection. Now let us consider another example. The collection of all beautiful flowers. Can you say which are the beautiful flowers? Let us see some flowers. Can you say which flower is more beautiful? No, that may different to person. We cannot say which are the beautiful flowers and which are not beautiful. Okay, another example, the collection of most dangerous animals of the world. We cannot say which animals are dangerous and which animals are not dangerous. Okay, without any doubt. And another example, the collection of good films by Mammootty. We can say which are the films that acted by Mammootty, but we cannot identify which one are good and which one are not bad. Okay, that is different from person to person. Another example, the collection of all intelligent boys in a class. Okay, we cannot say which boys are intelligent and which are not intelligent. And the last example is the collection of all beautiful girls in a college. This is also in the same way. These are some collection, and we cannot say which object or which elements belongs to this collection and does not belong to the collection. Okay, so far we have discussed two groups of collection. First group is this one, these five collections. What are the common property? What is the common peculiarity of this collection? These collection are well defined. This collection are well defined collection of object. We can definitely say which object belong to the collection and which object does not belong to the collection. This collection is known as set. Okay, then what do we mean by set? Set is a well defined collection of objects. Okay, now consider the second set, that is the collection of all beautiful flowers, etc. What is the common peculiarity of this collection? These are not well defined. These are not well defined collection. Hence, these are not set. Then what is a set? Set is a well defined collection of objects, and what is not a set? If the objects are not well defined, that collection is not a set. Now write this fact in your notebook beautifully. Write chapter number 1, sets. Okay, then write the subheading set. What is a set? What is the definition of a set? A set is a well defined collection of a distinct object. Say with me, a set is a well defined collection of distinct object. Then what do we mean by the word well defined? By the word well defined, we mean that we can definitely say whether a particular object belong to or does not belong to the collection. Okay, we can definitely decide whether a particular object belongs to or does not belong to the collection. Clear? Now write some examples for sets. These are some examples for sets. After writing these, write example for not a set. That we have discussed before. 5 examples for not a set. Clear? Why these are not set? This collection is not well defined. We cannot say whether a particular object belongs to or does not belong to these collections. That is why we are saying that these are not sets. Okay, now write some notes relating to sets. First note, set is a new thing for us, so we want to name it. How can we name set? Sets are usually denoted by capital letters in English, which are the capital letters A, B, C, etc. So we usually denote sets by capital A, capital B, capital C, etc. For example, let A be the set of all natural numbers less than 5. Which are the numbers? Which are the natural numbers less than 5? 1, 2, 3, 4. Hence, 1, 2, 3, 4 are the numbers or are the objects or the elements in the set A. That is, second, notice this, object of a set are also called elements or members of the set. Object, elements, members are synonyms. They denote the same thing. Object, elements and members represent the same thing. Clear? Now, we say that capital letters in English represent sets. Then how can we represent object of a set? To represent object of a set, we use small letters in English, A, B, C, etc. To denote object or elements or members in a set, we use small letters, and to denote set, we use capital letters. Okay. Fourth one, if A is an element of a set, then we write. If A is an element in the set capital A, then how can we represent it? For that, see the example. Let A be the set of all natural numbers less than 4. Which are the natural numbers less than 4, or which are the elements in the set A? That is 1, 2 and 3. Clearly, 1 is an element in the set A, 2, 3 are also elements in set A. Then we write 1 is an element in A like this, 1 belongs to A. This letter, this symbol is not the letter E in English, but it is Greek letter epsilon. Greek letter epsilon. Do you know which are the Greek letters? How many Greek letters are there? Just like as in English, there are 24 Greek letters. Let us see. alpha, beta, gamma, delta, epsilon, zeta, eta, theta, lambda, kappa, lambda, mu, nu, psi, omicron, pi, rho, sigma, tau, epsilon, phi, psi, phi, and omega. These are the 24 Greek letters. Okay. So since one belongs to, one is an element in A, we write one belongs to A like this. What about 2? 2 is also belongs to A, so we write 2 belongs to A, 3 belongs to A. In general, if A is an element in capital A, then we write small a belongs to capital A, and we read this as A belongs to A. Okay, if A is not an element of A, then how can we represent it? Like this: A is not an element of A, and we read A does not belong to A. Clear? For example, see here, A with the set of all natural numbers less than 4. Clearly 4 is not an element in the set A. Then we write 4 does not belong to A like this. What about 0? 0 is also not an element in the set A, so we write 0 does not belong to A like this. 5 does not belong to A, 6 does not belong to A, 100 does not belong to A, and so on. Okay, so write these in your notebook beautifully. Let us stop today's discussion here after giving you some assignment. This is the first assignment. Classify the following into sets and not a set. Write the question first, then write your answer. If this is a set, then you write set. If it is not a set, then write not a set. Second assignment is this one: insert appropriate symbol belongs to or does not belong to in the blank spaces. If 5 is a member of this set, then you write 5 belongs to A. If 5 is not an element of this set, then you write 5 does not belongs to A. Okay, today's class is over. Dear children, I have a simple request to you. Try to learn the concepts that we have discussed today now itself. Don't extend it for tomorrow. Wish you all a nice day. Thank you. Goodbye.